Hey everybody, this is Mr. Ainsworth. Let's greet each other properly. Good morning. Hey, we're going to get into a lesson here on how to solve systems by what's called substitution. All right. So our goal today is to not only learn the technique of solving systems called substitution, but also to interact with the T84 and to also go over what's called the three special cases of systems. Okay. So what we want to do throughout all of these examples here is we want to solve each system by substitution. We're going to state the solution as an ordered pair. And we're going to do the third thing is we're going to use the TI-84 and we're going to verify the solution, both manually on paper and with the TI-84. So we got three things we need to do here. Number one, we got to solve. Number two, we're going to state the solution. Number three, we're going to check and verify the solution manually and with the TI-84. So quite a bit to do. Get your red pen out. Also, take your calculator out, your TI-84. Put it off to the side. We'll use that a little bit here. Make sure you reset your calculator so it says RAM cleared, so everything's looking good. All right. But first, let's go ahead and let's learn how to do it with a basic example, and see how it goes. So we have a system here: y equals negative 3x plus 11, and the other one, negative 3x plus 2y equals 13. And notice here that we have one of the variables isolated. I see right here that we have the y variable already isolated, and that's a good thing. And I chose this example because it's fairly simple. You already have a variable isolated. The first general step, and let's put them on the left here in red, big and bold so they stand out, is to isolate either the x or y variable. Okay, isolate, get by itself. Okay, either x or y. Okay, in either equation. All right. So if one of the variables is not isolated, you need to isolate it, and always pick the one with a coefficient of 1. And we'll talk about that throughout the exercises, and we'll see and determine, which variable is the easiest to isolate in which equation. All right. This variable y is already isolated, so I can skip step 1 and go right to the major step right here, which is step 2, which is substituting the value or the quantity into the other equation. Okay, substitute, and that's where this name comes from. Oh, not substitution, but substitute. There we go, substitute. All right, into other, okay? The other equation, EQ's equation. So what we're going to do is we're going to take this, what y is equal to, which is negative 3x plus 11. Let's circle that. And we're going to substitute it in for y because it's equal to y. When any two quantities are equal, you can replace one with the other, or what we say substitute. This is where we want to do our substitution. We want to take the y variable out and replace it with negative 3x plus 11. So let's see what happens when we do that. Let's go to the right-hand side and read the equation from left to right. We've got negative 3x here. Right small because we have a lot to do. Plus 2 times whatever y is. Put parentheses there for the quantity because we're going to replace that with negative 3x plus 11 in a minute. And that's equal to 13. All right, we want to substitute in right here our y value, which is negative 3x plus 11. So notice that y comes out and what y is equal to comes in. That's the substitution right here. That's the critical step. And notice that we have an equation with just x. So my next major goal right now is to solve for that variable. Okay, we want to solve for the variable now. Okay, so let's go ahead and do that. Let's distribute through. All right, distribute through the 2 properly here. So we got negative 3x plus negative 6x. 2 times negative 3x is negative 6x. And 2 times 11, 22. And that's equal to 13. We always try to add like terms, and I see some like terms right here. Negative 3x plus negative 6x is a negative 9x plus 22. That's equal to 13. Always add the opposite first before you do any division. It's easier. So subtract 22, or you can say add a negative 22 to both sides, however you want to say it. These opposites cancel out to 0, as you guys already know. So we have negative 9x equals 13 plus negative 22, which is a negative 9. Then it should be obvious that x has to be 1 because negative 9 times 1 equals negative 9. But if that's not clear enough, let's go ahead and divide by -9, and you'll see that you get 1. Now in a system, the system or the solution to the system is an ordered pair, and it's always x comma y. We found x, but we've got to find y, so let's go ahead and do that. Now you have to substitute this value back into one of the equations, and since the first equation here, y is already isolated, you should choose that one. All right, so I'm going to rewrite the first equation right here, y equals -3x plus 11, so I can work with it here. And I want to take this x value and I want to substitute it into the x variable here. Why? Because I know x is 1. So the equation is telling me that y is equal to -3 times whatever x is, which is 1, plus 11 more. That's what it's telling me. So notice that I substituted that value in right here. We've already found that x is 1, so substitute 1 in, multiply by -3, and add 11, and you get the y value. So y is equal to -3 now plus 11, which is equal to 8. So my solution as an ordered pair, which is always x comma y, in this case it would be 1 comma 8. Okay? And that's my solution to the system. But it'd be kind of nice to know, how to check your system or your solution here. How do you check that, and how do you do it manually, and how do you do it with the TI-84? So let's talk about that. How do you check, all right, your solution? So let's go down here a little bit and take a look at that. All right, since the intersection point is on both lines, verify that it's a solution to the system. You do this by substituting, all right, into both, okay, both equations, and show that it is a solution to both. So what I need to do is I need to take this and substitute here, and then I need to substitute in through here. So let's check it. I'm going to take 1 in, or substitute 1 in for x, 8 in for y, and see if we get equalities. Okay, so y is 8, so substitute in 8. Question is that equal to -3 times whatever x is plus 11? Well, x is 1, right? So all I did was I replaced y with 8, because y is 8. I replaced 1 in for x. That's called the substitution right there. And then you simplify it. So is 8 equal to -3 plus 11? And the answer is obviously yes. -3 plus 11 is 8. So the ordered pair 1 comma 8 satisfies the first equation. Let's see if it satisfies the second. And if it does, we're going to say, hey, we did it right. All my mathematics is correct, okay? Because the solution satisfies both lines because it's the intersection point of both lines. All right, so is -3 times x plus 2 times whatever y, is that equal to 13? I don't know. Let's check. Let's put the values in. 1 in for x, 8 in for y. Notice the substitution here and here and here. All right, 8 in for y. And then go ahead and simplify. You got to, whatever side is not simplified, you got to simplify it and see if it's equal to 13. So you got -3 plus 16. Is that 13? Of course it is. Okay, 16 minus 3 is 13, and that's equal to 13, so it checks out. So at this point, I know I did my arithmetic correct. I know I solved the system correctly here. All right. So what you do is you solve it and then check it, and you can also check it on the TI-84 as well, which we're going to do right now. All right, so what we want to do is we want to reset the calculator first. So go hit second memory. All right, select number 7 for reset. All right, select enter and select number 2 for reset. And if you did it properly, it should say RAM cleared. Okay. Okay, and once you do that, you have to enter the equation. So hit y equals and enter your first equation in, -3x plus 11, -3x, and then plus 11, and go down to enter in y2. But notice that y2 is not in slope-intercept form, so we have to get it there. So let's go to the margin here, and let's create some space. Let's isolate y here, guys. Everybody turn to your partner and say, isolate y! Okay? It's a very important skill because you cannot enter an equation in standard form on a T84. That's a limitation of it. So the equation is -3x here plus 2y is equal to 13. Okay, add the opposite first. And you get 2y is equal to 3x plus 13, and divide everything through by 2. and you get y is equal to 3 halves x plus 13 halves. And this is what we want to enter in the T84. So let's bring your calculator back and let's go for it and let's check our solution. 3 divided by 2 x. By the way, you don't even need to make this improper or, mixed or even a decimal. The calculator can handle it all. All right, so just type it in, plus 13 divided by 2, 13 halves. All right, hit the graph button, and let's take a look at this. And there's your first function, and there's your second function right here, and it's going to be intersecting up here. All right, right 1 up 8. Let's find that intersection point. So hit second trace for the calculate. You have to calculate the intersection. Hit number 5 for intersect. And the calculator is going to ask you some questions. Let me try that again. Second trace, number 5. Okay, it's going to ask you what's the first curve, and it's y1, so hit enter, accept that. What's the second curve? y2, accept that. Put me at your guess, and move the cursor to the intersection by using your right or left arrow keys. Okay, and then hit enter for the third time. And look at this, guys, it says 1, 8. Holy cow, it's the same thing as what we came up with here. All right, so let's go ahead, and I'm going to clip this screen in here so we can see it. There we go. All right, and so the calculator verified it. We verified it by hand. We verified it with the calculator, and we're coming up with 1, 8. All right, check it out. The same thing right here. X is 1 right here. Y is 8, and that's 1, 8. And that happens to be right here, 1, 8. Right 1, up 8, right at the intersection point. So you can verify it a couple different ways, guys, on paper and on the T84. Okay? All right, so let's get some experience in through here, and let's go down here and see the different things that happen with the substitution method. All right, so here we go. Let's go ahead and substitute in again. Let's get your red pen out. Since y is already equal to 5x minus 8, all right, let's go ahead and substitute that in. And I've got 15x minus 3 times whatever y is equal to negative 3. And notice that I just read it from left to right. And wherever I see y, I substitute what y is equal to. It's called a substitution. So bring in y, which is 5x minus 8. Substitute that in there. And then solve for x. Okay? So you don't have to isolate anything because y is already isolated. Only in example 3, that's the first one where we have to do some isolation. But here, it's fairly simple. So distributing through, we get 15x minus 15x again, minus, no, not minus, but plus, right? Negative 3 times negative 8 is positive 24, and that's equal to negative 3. Collecting like terms, I get 0 here, plus 24 equals negative 3. And we get this weird condition here. We got 24 equals negative 3, which is obviously false. So the question is, what does that mean? So graph the system to understand, okay? So what do you do when you get a situation like this for the first time? And what does false indicate about the system? So let's graph system, and let's isolate y in this case because y is not isolated. So we're going to have to do the same thing we did on the last one here, because you can't input functions in the T84 unless they're in slope-intercept form. Okay, so let's do that. So we get negative 3y. Make sure you write down negative 3y is equal to negative 15x minus 3. Divide everything by negative 3. And you get y is equal to 5x plus 1. Okay, so the first function y1 is 5x minus 8. The second function y2 is 5x plus 1. They have the same slope but different y-intercepts. Ooh, they're parallel. Let's take a look at that. So let's go back and hit y equals, hit clear, go down, hit clear again, and then go back up to y1 and enter in 5x minus 8. Go down to y2 and enter in 5x plus 1. Hit graph, and you'll see that they're parallel because they have the same slope of 5. Now, solutions to the systems are the intersection points. And if they're parallel and offset, well, they have no intersection. And that's why when you go to the calculator and you try to calculate it, you're going to have a problem. Let me go ahead and clip this in here. so you can see it. Okay, so we have parallel lines here with no intersection. So what's happening here, my friends, is that false here indicates that there's no solution to the system because the lines are parallel. So we got to write a statement here. We're going to say no solution, all right, because the lines are parallel and apart. No solution, lines are parallel. And you can say offset, or you can say apart. Okay, there's no intersection point. No intersection. No intersection. All right, you can just see they don't intersect, so we respond no solution here. So when you solve a system by substitution, you end up with something weird like 24 equals -3, which is false. Okay, that indicates that the lines are parallel and apart, and you respond by saying no solution. Remember that, okay? You saw that in the graphing method in the first set of lessons, and now you see it again in an algebraic lesson. All right, now let's take a look at a little more sophisticated case where none of the variables are isolated here. And you want to pick the variable that has a coefficient of 1. And here I see the coefficient, or x has a coefficient of 8. Here y has a coefficient of 2. X has a coefficient of 4. Oh, y has a coefficient of 1 right here. So that is the one you want to isolate first. Isolate y here. So let's go ahead and do that. So we're going to have 4x plus y equals 24. We want to subtract 4x. And opposites cancel out to 0 here, and I've got y is equal to -4x plus 24. Okay, well, I want to substitute that in for the y variable, so I take this right here, what y is equal to, and I substitute it in here, in for y. SUB for substitute, okay? That's my substitution. So what do I get? I get from left to right, I get 8x plus 2 times whatever y is. 8x plus 2 times whatever y is equals 48. Equals 48. And I want to substitute that value in. Okay, so here we go. I'm going to take -4x plus 24 and substitute it in. Okay, then you go for it. Distribute through the 2. So I have 8x plus -8x. Or you can say -8x, same thing. So distribute once, distribute twice, plus 48 equals 48. Adding like terms, I get 0 here, plus 48 equals 48. That means 48 equals 48. That's obviously a true statement. Okay, but what in the world does that mean? Okay, well, we have to understand that, and we understand that by graphing. So my second equation, y2, is already solved for y. I already did the work here. So what I need to do is I need to isolate y on the first equation. So 8x plus 2y equals 48. I'm going to subtract 8x here, and I get 2y is equal to -8x plus 48. And if you divide everything by 2, I get y1 is equal to, y1 stands for my first equation, okay? So don't let that confuse you. Equals -4x here, -4x plus 24. Holy cow, look at this. They're the same equations. And if they're the same equations, that means they are the same lines. And if they're the same lines, my friends, they overlap everywhere. And that's why this system has an infinite number of solutions, okay? Because they intersect everywhere, they're the same lines. All right, so we respond by saying an infinite, okay, an infinite number of solutions, or you can say infinitely many, infinite number of solutions. So you've seen 3 cases so far. Case 1, we saw that we have a solution right here, okay, 1, 8. We verified it manually on paper. We substituted in both equations, verified it, and then we verified it on the calculator. Case 2, they're parallel, and we had a false condition which indicated no solution. Case 3, we have a true solution, or true case, where we have an equality, 48 equals 48, and we isolated y in both cases, and we found that they're the same lines, so they intersect everywhere, and that's the reason why we have an infinite number of solutions. So you either can have one solution in example 1, or no solutions, or an infinite number of solutions. There are 3 cases possible. Now you just have to get used to that by, obviously gaining some experience. So let's go ahead and do that, and let's continue here. And let's go on to number 4 and see how we solve 4 through 6. Okay, now these are slightly different, right? Because, you're going to have to get experience on different solutions, or excuse me, different systems. Well, here I see y is 2. This is the easiest case in the world. I just say, hey, since y is 2, substitute it in, and I get 2 equals. All right, 2 equals negative 5x plus 7. I already know what y is equal to, so the only thing I need to do is find x, and then I'm done. So subtract 7, and I get negative 5 equals negative 5x, divide by negative 5, and I get 1 is equal to x. So my solution is a very simple one. Okay, it's always x and then y, and so in this case it's 1, 2. Why? Because y is already 2. It's already solved for. So sometimes you have to really think simple because this is a simple system. Y is already known, so the only thing you have to do is find x, and that's it. Okay, now in this system here, number 5, the only thing that you have to do is make your substitution because both equations, y is already isolated. So just take one of them, all right, and substitute it in for the other one. So what do I get? I get not y, but 3x minus 10 is equal to negative 6x minus 1. Substitute in first, then solve for x. So let's go for it. Let's add the opposite on both sides and line up like terms. Let's add the opposite again here. 10 minus 1 is 9, and so x has to be 1. 9 times 1 is 9. And then you just substitute back again. You got to take that and substitute it in here. Either equation, it doesn't matter, to find y. So let's go ahead and do that. Y is equal to negative 6 times whatever x is minus 1. Negative 6x means negative 6 times x minus 1. What is x? Well, it's 1. So y is equal to negative 6 minus 1, or negative 7. So my solution here is pretty simple as well. It's 1, negative 7. All right, and the last one here is the most challenging one here. You have to isolate y, so let's go ahead and do that. Let's put that big bold in red here. All right, and let's write it as negative 2x minus 3y equals negative 16. Let's start isolating y here by adding 2x. And I get negative 3y is equal to 2x minus 16. Divide through by negative 3. And I get y is equal to negative 2/3 x plus now, because we got double negative, 16/3. Okay, and now what we want to do is we want to substitute. That's where the name comes from. Okay, substitute in for the variable. It's equal to y, so substitute it in for y. And so I get negative 8x minus 6 times all of this. So negative 8x minus 6 times all of what y is equals negative 4. And I need to substitute that in. So I need to bring in my negative 2/3 x plus 16/3, leave it fractional, and distribute. So I get negative 8x. Now, first thing you do is you handle the signs. A negative times a negative is a positive. So handle the signs first. And then 6 times 2 is 12, divided by 3 is 4, times x is 4x. So you start by multiplying the numerator. 6 times 2 is 12, divided by 3 is 4, times x is 4x. And then you distribute the second time. Now, a negative times a positive is a negative, so put down the minus sign, and always handle the signs first. A negative times a positive is a negative. And 6 times 16/3, well, 6 times 16/3, divide first, and then multiply, and you get 32. So do a little side work, and then continue. All right, adding like terms, we get negative 4x minus 32 equals negative 4. Add the opposite. You get negative 4x equals 28. And if you divide by negative 4, you get x equals negative 7. We're almost done. So what we need to do now is find y. So we substitute it back. Now I'm probably going too fast for most of you guys. So remember, this is a video, and you can always replay and pause and replay and rewind and listen to this as many times as you need to. So go ahead and do that. That's the advantage of the video. So what do we get? Okay, so you get y is equal to negative 2/3 times negative 7 plus 16/3. Keep everything fractional. Y is negative 2 times negative 7, that's 14. So I get 14/3 plus 16/3. That's 30/3 or 10. Divide there. So my solution is known now. Okay, it's negative 7 comma 10. All right, there you go. And that's the substitution method. And you just have to get good at it and get used to it. So do your homework that's attached and check your work. Make yourself proud. And remember, this is a video. So you can go back and watch this anytime or as much times as you need to. All right, so make yourself proud, do your work hard, ask a lot of questions, interact, and I'll see you in my next lesson. This is Mr. Ainsworth signing off. I'll see you next time.